The story began in July 2026, 4 years after the James Webb Space Telescope first opened its golden eye to the universe. By then, astronomers had grown accustomed to remarkable discoveries, yet nothing prepared them for what arrived on this particular anniversary. Two separate findings emerged almost at the same time. One uncovered a hidden planet that had been quietly waiting in plain sight for more than a decade. The other peeled away the dusty veil covering one of the strangest galaxies in the nearby universe, exposing details that no human had ever seen before. Before we uncover how these incredible discoveries unfolded, take a quick moment to subscribe to the channel. We are on the journey to reach 1,000 subscribers, and your support genuinely helps us continue bringing you real, carefully researched space stories like this. To understand why these discoveries mattered so much, we have to go back to the beginning of Webb's journey. When the telescope was launched, scientists knew they were building something unlike any observatory that had come before it. Instead of relying mainly on visible light like the Hubble Space Telescope, Webb was designed to observe the universe through infrared light. That single difference changed everything. Visible light struggles to travel through thick clouds of cosmic dust. Much like the headlights of a car disappearing into heavy fog, it scatters and fades before reaching what lies beyond. Infrared light behaves differently. It slips through those dusty barriers, allowing Webb to look directly into places that had remained hidden for decades. The telescope itself was built for exactly that purpose. Its enormous primary mirror, stretching 6.5 meters across and made from 18 precisely aligned gold-coated hexagonal segments, collects far more light than Hubble ever could. Combined with instruments designed specifically for infrared observations, Webb became capable of revealing structures buried inside dusty regions that previous generations of telescopes could never hope to see. 4 years after its first public images, the telescope was performing even better than its designers had predicted. To celebrate that milestone, NASA and the European Space Agency released a remarkable new series of observations centered on a galaxy called Centaurus A. At first glance, Centaurus A hardly resembles the graceful spiral galaxies most people imagine when they picture the universe. Located only about 11 million light-years away, making it a close neighbor in cosmic terms, the galaxy appears twisted, chaotic, and uneven. But its strange appearance tells the story of an ancient disaster. Roughly 2 billion years earlier, Centaurus A had collided with another galaxy. The collision transformed everything. Vast quantities of gas and dust were thrown throughout the system, creating the raw material for countless new generations of stars. At the same time, enormous amounts of matter spiraled into the supermassive black hole at the galaxy's center, feeding it until it became an intensely energetic, active galactic nucleus whose brilliant core still shines today. Although billions of years have passed since that collision, the galaxy continues recovering from its violent past. Stars, gas, and dust slowly settle into new orbits across unimaginable timescales, giving astronomers an extraordinary opportunity to study what a mature galactic merger actually looks like. In many ways, Centaurus A offers a glimpse into the distant future of our own Milky Way, which is itself destined to collide with the neighboring Andromeda Galaxy billions of years from now. For years, astronomers believed they understood Centaurus A reasonably well. Hubble and many other telescopes had photographed it repeatedly. Yet one major obstacle always remained. A massive lane of thick dust stretched across the galaxy's center, hiding its most important secrets. No matter how carefully astronomers observed it, visible light telescopes simply could not see through that barrier. Then Webb looked. Using infrared light, The telescope pierced the dust as though it barely existed. Suddenly, the galaxy's hidden heart emerged in astonishing detail. Where earlier images showed only a dark, obscured center, Webb revealed thousands upon thousands of individual stars, intricate structures carved by the ancient collision, and unmistakable regions where entirely new stars were still forming. The familiar galaxy suddenly looked almost unrecognizable. Hidden within those observations was another surprise. Researchers discovered warm molecular hydrogen arranged in a warped rotating disk close to the central supermassive black hole. That single structure offered one of the clearest views yet of how black holes and star formation influence one another. For decades, astronomers had debated exactly how these enormous black holes shape the galaxies surrounding them. On one hand, their immense gravity draws gas and dust inward, compressing the material until it collapses into newborn stars. On the other hand, the tremendous energy released as black holes actively feed can blast surrounding gas back into space, preventing future generations of stars from ever forming. Centaurus A appeared to show both processes unfolding together. Instead of merely producing a sharper photograph, Webb had delivered direct observational evidence of the delicate balance between destruction and creation taking place inside a galaxy. For astronomers, it was like watching one of the universe's greatest balancing acts unfold before their eyes. What Webb had revealed went far beyond a clearer photograph. Hidden within those remarkable observations was direct evidence of something astronomers had spent decades trying to understand: the relationship between a supermassive black hole and the birth of new stars. At first, that connection might seem surprising. After all, black holes are usually imagined as cosmic destroyers, swallowing everything that comes too close. Yet the truth is far more complicated. Almost every large galaxy in the universe, including our own Milky Way, hides a supermassive black hole at its center. For decades, scientists have argued over one fundamental question: do these enormous objects help galaxies grow, or do they slowly choke the life out of them? Centaurus A offered one of the clearest opportunities ever to find the answer. As Webb examined the galaxy's hidden core, astronomers realized they were witnessing both sides of that story unfolding at the same time. The black hole's immense gravity was pulling surrounding gas and dust inward. As that material became compressed, it collapsed under its own weight, igniting brilliant bursts of newborn stars. In that sense, the black hole behaved almost like a giant cosmic engine, feeding fresh generations of stars into existence. Yet the same black hole was also releasing extraordinary amounts of energy. Powerful radiation and energetic outflows blasted through parts of the galaxy, driving gas away from regions that would otherwise have continued producing stars. In those places, the black hole was doing exactly the opposite, shutting star formation down by removing the very material new stars needed to form. For years, astronomers had predicted that both processes should exist. But seeing clear evidence of them happening together inside the same nearby galaxy was something entirely different. Centaurus A had become one of the finest natural laboratories anywhere in the nearby universe. Because it lies close enough for Webb to resolve remarkable detail around its center, and because its ancient collision left behind exactly the right conditions, astronomers could finally observe this delicate balance directly instead of relying only on computer simulations or indirect measurements. The galaxy was no longer simply an object in the sky. It had become a living demonstration of how galaxies evolve. While researchers were still celebrating those remarkable images, another story quietly emerged, one that seemed almost impossible. It did not begin with a brand new observation. Instead, It began with a mystery that had been hiding inside astronomical archives for more than 10 years. On July 15, 2026, two independent research teams announced that they had confirmed a third planet orbiting the nearby young star Beta Pictoris. At first glance, the discovery sounded like another addition to the ever-growing catalog of exoplanets. But this one was different. Beta Pictoris had already been famous for decades. Located only about 63 light-years from Earth and just 23 million years old, the star is extraordinarily young compared with our Sun. Around it lies a vast disk of dust and debris, the leftover material from its birth, where planets are still taking shape. For astronomers, it has long served as one of the best natural laboratories for watching planetary systems form almost in real time. Over the years, scientists had already discovered two giant worlds there. The first, Beta Pictoris b, was found in 2008 and became one of the first exoplanets ever to be directly photographed. A second giant planet, Beta Pictoris c, followed in 2019. Most researchers believed they understood the system remarkably well. They were wrong. Hidden inside archived telescope observations was another world. For more than a decade, it had quietly appeared in image after image, too faint to attract serious attention and too easily dismissed as background noise. Nobody realized they had been looking directly at a planet all along. The newly confirmed world would eventually receive the name Beta Pictoris d. To appreciate why this mattered, it helps to understand why Beta Pictoris has fascinated astronomers for so many years. Its enormous disk of dust and rocky debris is still actively evolving. Unlike our mature solar system, where planets finished forming billions of years ago, Beta Pictoris allows scientists to witness the process while it is still unfolding. In 2024, researchers even found evidence suggesting that a massive asteroid collision had recently taken place somewhere inside that disk, making the system appear even more dynamic and active. Every new observation added another piece to one of the clearest pictures scientists possess of how planetary systems gradually assemble themselves over millions of years. Then came the discovery that changed everything. Unlike most directly imaged exoplanets, which appear simply as faint points of light beside much brighter stars, Beta Pictoris d had spent years sitting right at the very edge of detectability. A research team using the European Southern Observatory's Very Large Telescope in Chile finally recognized what previous observers had overlooked. When they carefully re-examined more than a decade of archived observations, they realized the faint signal had been present all along. It had never disappeared. It had simply been too dim to prove with confidence. Researchers estimated that the planet was nearly 100 times fainter than Beta Pictoris b, making it the faintest exoplanet ever directly imaged from Earth. Suddenly, years of overlooked data had become one of astronomy's greatest discoveries. At first, the discovery almost sounded impossible. How could an entire planet remain hidden for more than 10 years, while astronomers around the world had been studying the very same star system? The answer lay in just how incredibly difficult direct imaging really is. Imagine standing many miles away, trying to photograph a tiny firefly hovering beside an enormous searchlight. The firefly is there. The camera is pointed in exactly the right direction. Yet the overwhelming brightness of the searchlight completely drowns it out. That is almost exactly the challenge astronomers face when they attempt to photograph planets orbiting distant stars. A star shines with such extraordinary brilliance that the faint glow of a nearby planet is almost always lost within its glare, often hidden beneath light that is millions of times brighter. To overcome that problem, astronomers rely on highly specialized instruments known as coronagraphs. These devices physically block the light from the central star, allowing telescopes to search for the tiny amount of light reflected or emitted by any planets orbiting nearby. Even then, success is never guaranteed. Beta Pictoris d pushed those instruments almost beyond their limits. Researchers estimate that the planet is roughly 100 times fainter than Beta Pictoris b, which itself was already considered an exceptionally challenging target. Suddenly, everything made sense. The planet had never truly been invisible. It had simply been too faint. For more than a decade, it had quietly appeared inside archived telescope images, sitting right at the edge of what existing technology could reliably detect. Astronomers had not overlooked it because they failed to search carefully enough. They simply lacked instruments capable of proving that the faint signal represented a real world, rather than random noise or an imaging artifact. Then another team approached the mystery from an entirely different direction. Led by astronomer Aidan Gibbs at the University of California, San Diego, researchers turned the James Webb Space Telescope toward the same system. Instead of searching only for another tiny point of light, Webb looked for something far more distinctive. Every atmosphere leaves behind its own unique chemical fingerprint. As light passes through gases surrounding a planet, certain wavelengths are absorbed while others continue onward, creating a pattern that acts almost like a barcode, identifying the chemicals present. Webb detected exactly that. Its instruments identified water vapor, methane, and carbon monoxide surrounding the faint object. When those chemical signatures were combined with the object's position, motion, and alignment within Beta Pictoris's surrounding debris disk, the evidence became overwhelming. This was not a distant background star. It was not an imaging error. It was a genuine planet orbiting Beta Pictoris. The confirmation marked a historic milestone. For the first time, astronomers had verified a directly imaged exoplanet primarily through spectroscopic chemical fingerprinting, rather than depending entirely on conventional imaging alone. That breakthrough immediately suggested something even more exciting. If one hidden planet could be confirmed this way, how many others might already exist inside decades of archived observations, dismissed simply because they were too faint to identify through photographs alone? The possibility transformed old data into new treasure. Telescopes around the world had spent decades collecting observations. Perhaps countless hidden worlds were already waiting inside those archives, needing only the right technique to finally reveal themselves. The newly confirmed planet itself turned out to be fascinating. Named Beta Pictoris d, it is a gas giant estimated to contain between 2 and 2.5 times the mass of Jupiter, making it the smallest and faintest of the 3 giant planets now known to orbit the young star. It also travels along the widest orbit. At roughly 30 astronomical units from Beta Pictoris, it circles its star at a distance about 30 times greater than Earth's distance from the Sun. So far from its parent star, the planet receives far less warmth and light than its 2 larger neighbors. Its cold, faint nature had helped keep it hidden for years. Yet the discovery accomplished far more than simply increasing the planet count. For years, astronomers had puzzled over the unusual shape of Beta Pictoris's enormous disk of dust and debris. The disk contained subtle distortions that seemed almost impossible to explain. Many suspected that an unseen planet was responsible. Its gravity, acting over millions of years, would constantly tug on nearby dust and rocky fragments, gradually sculpting the surrounding material into rings, gaps, and warped structures. Astronomers often use exactly this method to predict unseen planets. Rather than observing the planet itself, they study the shape of the surrounding disk and allow gravity to reveal what remains invisible. Beta Pictoris had displayed precisely those clues for years. The warped disk was, in effect, a gravitational fingerprint left behind by a hidden world. Now that world finally had a name. Beta Pictoris d possessed exactly the mass, location, and orbit needed to explain every one of those mysterious distortions. A puzzle that had frustrated astronomers for years had finally been solved. The discovery also elevated Beta Pictoris into an exceptionally exclusive group. Only one other planetary system, HR 8799, had previously yielded more than 2 planets through direct imaging. For nearly 20 years, HR 8799 had stood alone as astronomy's only detailed example of a young system containing multiple directly photographed giant planets. Scientists often described such systems as the holy grail of exoplanet research. Unlike isolated planets discovered around unrelated stars, these systems allow researchers to compare several worlds born from exactly the same cloud of gas and dust, forming under identical conditions while following different evolutionary paths. One astronomer summarized the growing pattern with a smile. Planets seem to have friends. The more carefully researchers searched, the more frequently they discovered that directly imaged giant planets rarely lived alone. With Beta Pictoris now joining HR 8799 on that remarkably short list, astronomers finally possessed a second real-world laboratory for testing their theories of how planetary systems grow, evolve, and organize themselves across millions of years. For the first time, they could ask whether the remarkable architecture seen in HR 8799 represented a cosmic exception, or whether nature had been quietly building similar planetary families all along. For nearly 2 decades, HR 8799 had occupied a place of its own in astronomy. It remained the only known planetary system where scientists had successfully captured multiple planets through direct imaging. That made it an extraordinary laboratory for testing theories of planetary formation, but it also left researchers with a problem. Every conclusion rested on a single example. There was no second system against which those ideas could be tested. Then Beta Pictoris changed the picture. With the confirmation of Beta Pictoris D, astronomers suddenly possessed another real planetary family to study. For the first time, they could compare 2 independently formed systems and begin asking whether the patterns observed around HR 8799 represented universal rules of planetary formation, or whether that famous system had always been an unusual cosmic exception. Yet the true significance of Beta Pictoris D reached far beyond adding another world to an ever-growing catalog. By 2026, astronomers had already confirmed roughly 6,000 exoplanets scattered throughout the Milky Way. Discovering one more planet by itself would not have rewritten astronomy. What changed everything was the way this planet had been confirmed. For the first time, researchers possessed convincing evidence that a planet could be verified through the unique chemical fingerprint of its atmosphere rather than relying only on the traditional detection of a faint point of light. That single achievement quietly expanded the future of planet hunting. Somewhere inside decades of archived telescope observations, there may already be countless faint worlds waiting to be recognized. They may have appeared in image after image without attracting attention, not because they were absent, but because the technology available at the time could not prove they were real.